meeting live on YouTube. This one. Today is 20.8.2021. This is Zoom to YouTube. Zoom to YouTube. Perfect. And what else? Use that, right? Join the link here. Join in. I failed. Wait, what happened? Teach. แต่ว่ากดอัดไปแล้วใช่ไหม กดอัดไปแล้วโอเคมา fresh name no microphone อัดได้ไหมอัดไม่ได้ไลฟ์ไปที่ YouTube ไม่ได้ขอโทษที่ เราเล่น this YouTube yes this one right yeah this take this all right and yeah anything else nothing right in here โอเคมีเสียงไหมครับมีเสียงไหมเอ่ยมีใครเอกวัตรนะครับเอกวัตรคนไทยดีนะครับทินนะครับ all right I hope that voice is fine right มีเสียงอยู่นะครับที่อันนี้นะที่จากOBS นะครับ and yeah we have to share the screen right try starting yeah microphone ที่ซูมเสียงไปไหมครับที่ซูมครับที่ซูมเสียงไปนะครับ where should I see something yeah พิสุทธิ์มาแล้วนะครับรู้สึกว่าจะอัดพิสุทธิ์อยู่ที่ YouTube นะครับพิสุทธิ์อยู่ที่ YouTube นะครับคุณลองหาใน channel แล้วผมขี้เกียจส่งให้นะมันเสียเวลาแล้วครับผมส่งกันบ้านผลการตรวจการบ้านให้แล้วนะครับก็ประมาณนั้นI have to open a new file right oh my god new file has to be there oh please this one copy the iCloud drive alright in มีคน3 คนที่แชทใช่ไหมครับแชทเหรอก็มีธีนพัฒน์นะครับปัญญะวีรพัฒน์แล้วก็ทัชกรนะครับที่พิมพ์ชื่อมาครับตอนนี้นะครับจะมีกองถึงiCloud Drive copy in Suankularb yeah this one 2 คนทำไงcopy iPad like this I said so and then we open it in the SCI right new which one import thisโอเคชวินมานะครับเขาวัดนะครับแล้วก็พัดโอมีคนรอนะครับขออภัยนะครับso we would startที่ YouTube นะครับมีพิสุทธิ์นะครับแล้วก็พระภาวิทย์นะครับแล้วก็สุรปวีณนะครับไม่รู้ว่าที่ซูมเสียงโอเคหรือเปล่านะครับคุณไม่ตอบผมเลยนะที่ YouTube เนี่ยผมเช็คอยู่นะครับเสียงใช้ได้อยู่ alright oh no the Zoom he didn't turn on we didn't turn on yet the microphone, right? Okay. ที่ซูมนะครับที่ซูมเสียงไปไหมครับเวลาสิทธิ์พิมพ์มา All right, now we live at we have finished it the story about the galvanometer, right? มาแล้ว yeah, I hope that everything is fine. All right, yeah. On which page? This one เวลาเขาเปิดหน้านี่อย่างนี้ครับเป็นเยอะๆเดี๋ยวครับประธานินแป๊บหนึ่งนะครับthis one right okay all right yeah okay มาพี่เชษพงศ์มาเลย2 พิมพ์มา okay all right yeah when the audio works perfectly I would leave the headphone right now okay and yeah we are going ahead with that กับภาวิทย์อยู่ที่ช่องนี้นะครับ all right and this one I'm not sure yeah direct current yes yeah direct current model right we are live at the story in yeah it's the first type of the motor that you can apply right motor is the device that converts electricity or electrical power to mechanical power in terms of torque right we have applied the torque we have you got to know already the concept of the torque right which is the couple force onto conductor loop right anything else nothing okay yeah it's the motor will be more complicated than the solenoid that you have seen okay because the purpose of the motor is to deliver the mechanical torque right and the good quality of the torque is that we should have the continuous torque okay in every revolution or rotation okay and that's the reason why we have several pairs of conductor okay this is the pair and this is the pair of the conductor okay and the upper and the lower will be connected to each other at the end okay or at the rear of this motor and yeah and we connect the motor okay because this is the kind of motor which is the direct current motor right the power supply okay the unit that supplies the electricity to the motor will be the direct current source okay for example battery or any kind of direct current power system for example in Japan they have also direct current power system to deliver to the users at home. Okay, any kind of direct current source, for example, the electricity from the solar cell and so on. Okay, it's not limited to only battery. Okay, but at least there should be two polarities, the plus one and the negative one. Okay, we connect the plus one to the black line here. All right, the black line here in ครับอยู่ที่นี่17 คนนะครับ we connect the power source or direct current source to the motor by using firstly the black one, okay, which is the copper wire, okay, on both plus side and negative side. And later on, the black conductor is connected to this unit. Okay, you can see here, and we cannot see it completely on another side. Okay, because this part of just obstruct the view of that. It seems like a cubic. Okay, okay, it looks like a cubic, but it's not really cubic. It has the shape like this. If you want to take a look, I will give it to you. It has the shape like this. Okay, yeah, because this is the more simple type of the model. Okay, they use such type of device. Okay, it is called brush. Okay, it's like you have toothbrush and so on. Okay, brush. It's made of carbon. Okay, and the function of this device or this piece is that to pass the current to any pair of the conductor. Okay, when for example the magnetic start from this side, okay, to this side. This is the magnetic field line, right? Start from one pole to another pole, and I don't understand why they say the magnetic field line start from the south pole to the north pole, but actually, as we have learned at the beginning of this chapter, the magnetic field line should start from the north pole, right? But I don't know, they write in the opposite way. Here here you can see that the current start from this side, right? And of course the current will pass the brush, okay, and then to any touching conductor, okay, or copper wire like this, right? This wire is connected to this one, okay, and both are the pair of each other, right? And yeah, the current will go. No, I don't want it. Here, the current will go from this one, right, to this conductor, and it will return to this side, right? In according to the FILB, right, you can see that the vector L is going to point in this way, right? Vector L, and vector B is gonna be like this, right? This is vector L, this is vector B, but it's actually 90 degrees to each other, right? So you would have something like this, and then you cross it, all right? Cross it from L to B, right? And you will get from the right hand loop the induced force, right? Pointing เดี๋ยวแป๊บนึงนะครับพวินนะครับเดี๋ยวผมลืมทิศนะครับโอเค you will get the force pointing downward, okay, on this side, okay, all the way here, okay. It's not only a single point. Yeah, that's what's going on this side, and on this side you see that the current flow from the back, okay, the rear part of this the current motor, and then it goes to this way, right? In yeah, you can see that at this on the right side you get vector L like this, right? A vector L, and vector B is gonna be this way, right? But this angle is 90 degree, right? And yeah, you oh no, here you have to curl your four fingers, right, from the first vector L to the vector B, right? And you can see that by using your right hand, you get the induced force, all right, in this way, okay, upward direction. This is the induced force on the right side, okay. This is the induced force on the left side, okay. Here is the figure that happens regarding the induced force on the left side, okay, on this in this model. And here is the figure that illustrates how the induced force happens on the right side of this part, okay. I forget to mention that the whole body here is the frame, okay, or the main body of this model. And you can see here the circle inside, and all along this way it's just a cylinder, right? And this cylinder is called shaft, okay, shaft. This one, okay. ภาษาไทยเรียกว่าเพลานะครับ okay ไหม and yeah, the yellow one is conductors. And this cylinder is called rotating part, okay, but it's well known in machinery society, okay, which is a subject in electrical engineering, that it's called rotor, okay, rotor. And this part, okay, the smaller circle, and it's just pointed out of the cylinder, okay, the rotor. The functionality or the task of these parts, which is called commutator, okay, the functionality of the commutator is that to get the current, okay, from the source, okay. And as you know, you have induced force upward. On the right side, you have induced force in the downward direction. Of course, this is the torque, okay, the couple force on both sides of the rotor of any object, okay. This shaft, or this rotating part, it's called simply called rotor. It's gonna turn away, right? It's rotate like this, okay, in the counterclockwise direction. And when it moves, this one, okay, this conductor which is connected in this way, okay, go along the way behind the rotor at the rear part of this motor. This one will go to this position, okay, and this one, okay, will replace the position of this one, okay, and both are the pair, okay, belongs to the pair of each other. And of course there will be again induced force, okay. You know, here we have another pair. We have the second pair, the third pair, the fourth pair, okay. You know that when it move, there will be always almost always torque that happens to this motor, right? And of course, you may ask me, could it rotate when the brush doesn't touch the conductor? It still rotates, okay. It still rotates because there is the so-called inertia, okay, inertia of the rotation, right? Because the rotor has a mass, it's not 0 kilogram, right? So that would happen. ขออนุญาตเปิด good note นิดนึงนะครับ ไม่รู้ว่ามันจะกินแบนด์วิดต์หรือเปล่านะถ้าเกิดเปิด good note นะ where is the good note โอ้ไม่เจอall right here. All right. Yeah. Yeah. There is inertia, right? And the rotation will have the smooth Okay, almost all the time the torque that happens to this rotation, and that's the whole thing about the the direct current motor, right? In nothing more, right? Yeah, uh, yeah, everything is already described or explained it. Here, stationary part, graphite, okay, is called brush, okay, and you may have ever heard that sometimes we get trouble with the direct current motor. It doesn't work, okay. The reason is that because there is always uh, friction, right? And the rotation will wrap the surface of the brush, okay, that contacts the commutator all the time. And you know that the brush is decided to get a smaller space, okay, when it has friction. And some day, okay, when you use the motor for several hours, the brush is going to diminish, okay, the size of brush will be thinner, and finally it becomes zero thickness, okay, it has zero thickness, and the brush disappear from the whole system. And in that case, you cannot have any device, okay, to deliver the electric power to the rotor of this motor anymore. And at that time, you would not be able to use the motor to work in this case, okay. And yeah, that's the end of the direct current motor with a specific type, okay, that use brush, okay. This is the simple type, the ancient type of the direct current motor, but it's acceptable. It's quite simple to make, okay. But nowadays they have even กสิดิตส่งรูปมาอ๋อครับผมเข้าใจครับyeah, that's the end of the day for the direct current motor when it just drop all the time, and this part just disappear, okay, from the system. The one thing that we could do to this broken motor is that we just take it out, okay, and then we replace the brush, okay. And for some day when the brush almost disappear, okay, then you get some symptom of the direct current motor, okay. You may not get continuous torque, okay. You will see that the motor sometimes turns, sometimes doesn't rotate, okay. And that time you could imagine that it's the time to replace the brush, okay. Yeah, and yeah, that's the whole thing about direct current motor. In what else? In some case, they don't use the permanent magnet, okay. This is the permanent magnet, and yeah, permanent magnet is a rare earth, right? So we would not find this metal easily on Earth. Sometimes we need to replace it by using this coil, okay. This is another group of coil, okay, on the left side, and this is another group of coil, okay. And according to the Biot-Savart formula, B equal mu 0 I divided by 2 pi R or 2 pi D, right? You can compute the magnetic flux density, okay, from this loop of. This is another group of apart from the coils inside the rotor, okay. This is a fixed position, okay. This coil just located in a fixed position at the stator, okay, or static part of the motor, okay. It's this one is the frame of the direct current motor, and it doesn't rotate, it's just stay constantly, okay. And it's called static part, or simply speaking in electrical engineering we call stator, okay. It's like rotor stand for rotating part. ก็เดี๋ยวเขียนให้แล้วกันนะครับsorry rotor ro rotating part. All right, and stator just come from static part. Static part. Okay, or component. Yeah. We simply say rotor or stator, okay, in electrical engineering, because it's not convenient to all the time say rotating part or static part, okay, it's not convenient. Just simply use the shorter words like rotor or stators. Well, the conductor here should be insulated, okay. You should leave it into material in liquid form, and after that it get rigid, and it just functions as the insulator, okay, so that it will not let the current flow through the rotor. Usually the rotor is made also another kind of metal, okay, but the purpose of the rotor is not to deliver the current flow, okay, but it doesn't serve for the current flow. It just build up to poles, several pairs of conductors, and it should be rigid enough. It should be light, okay. If you have the heavy metal at the rotation part, you would lose some energy because of friction and inertia and so on, right? And the whole weight of the whole motor is going to be so much, okay. We don't prefer the heavy motor. All right, the counterclockwise torque will happen, and another way, okay. This is the simplest case, okay. You can imagine how the direct current motor work, okay. I have several types of figures so that you would understand. All right, here they just connect the positive side of the battery or any direct current source, okay, DC power source, to this one, and this one is called brush, right? And when you have two amounts of them, you would say they are two brushes, right? Yeah. And the one served for the negative side, okay, is connected to the conductor, and it just take the electron, all right, on this side from the direct current power source, and this one, the current is the current flow side, right? And there is another device that may be new to you, okay. This one is split link, okay. It's called split link. I'm sorry for that. Split link นะครับไม่ได้สอนวิชาพวกมอเตอร์มานานครับก็จะลืมคำสับสนนิดหน่อยครับ It's like you have a small circle and you have cylinder like this, okay. It's like a pipe, but you cut it, okay. It should not be so long, okay, but the thickness should be a little bit greater than the width of the brushes, okay. And the way to make the brush, okay, if you have the ring like this, รู้จักแหวนใช่ไหมครับที่ใส่นิ้วนั่นแหละครับทรงอย่างนั้นนะครับโอเคไหมif you have the ring like this, sorry if you have the ring like this, it's also used in advanced motor, okay. It's called a slip ring, okay, and usually people prefer slip ring, okay, instead of the split ring, okay. And what is split ring? Split ring is like slip ring, okay. You just have the circle and you have the ring like this, and the way to build up the split ring is that you just cut this part, all right. Here the upper part and the lower part, and you sorry for that, and then you just leave it, okay. Lay down the cutting part like this, okay. So now you have a pair of broken links, right? But it's very useful for the direct current motor, okay. Slip ring will be used in a more advanced motor, okay, because it's better. It doesn't is would be used for the alternating current motor. Okay, and in that case, it would you can adjust the speed, okay, the revolution per minute (RPM) of the AC motor by using the frequency of the AC current, okay, the alternating current. But for us, at the basic step, we consider the direct current motor. Okay, we have to deal with the split link. Okay, this one is called split link. Yeah, and the direct current, the positive side, right, is connected to this part, and of course it will allow the current flow through the one side of the ring right here. You may ask me, what is the function, what is the purpose of split link? Split link is the device that that is decided for delivering the current, okay, with almost 180 degree, okay, because in one circle you have 360 degree, right, and you cut half of both half of them, you get almost 180 degrees, right? But you have to lose a little bit of degrees here, okay, of angle, because it's the cutting area, right? And almost 180 degrees, okay. In all these 180 degrees, you still deliver the current to the conductor, all right. And of course, this is the positive side. The current will flow in this way, right? When the current jumps from the brush to the slip link, to the split link, the split link will further transfer the current to the conductor, okay, which is the conductor in the rotor, okay. You know the rotor, the rotation part, the shaft, the cylinder there, and the current will flow in this way. It just go like this, okay, and it flow further to another side of the conductor of the rectangle conductor loop, and it just come here, and of course it will touch the brush. It will touch the split link, and the split link will deliver the current to the brush. The brush will further send the current to the conductor, and it just reach the negative side of the battery. Okay, but the important thing for us is over here, right? As you know, the current flowing in this direction. Okay, we get on the left side, right? Okay, we get the vector L like this, right? In the magnetic field start from N to S, right? This one. ผมว่ารูปนี้เขาผิดนะครับรูปนี้นะครับmagnetic field นะครับไม่ได้วิ่งจาก S นะน่าจะเป็น N นะครับโอเคไหมเขากระแสน่าจะไหลอย่างนี้นะครับโอเคไหมเพราะว่าถ้าทิศ B มันไหลตรงนี้นะผมว่าน่าจะผิดนะตรงนี้นะครับน่าจะเป็น N นะครับแล้วก็ตรงนี้ก็เป็นS นะครับโอเคไหม South Pole yeah, you have the vector L right in this direction, and the vector B in this way, right? And here you have vector B, and you have to curve it from L to B, right? In yeah, L to B, right? You get the L to B, right? So it's gonna be the upward direction of the force, right? FL on the left side, and here on the other side you will see that the force is going to be downward. So you have vector L like this, and you have vector B like this. Sorry for that. That's vector L, that's vector B, and you just rotate from L to B. In L to B, right, you get downward direction of the force on the right side, and yeah, that's the force on the right side, and you get downward, okay, downward force FR, and you get upward force on the left, and both forces will will give you the torque, right? And this conductor will rotate according to the rotation direction here. Okay, in this way, if you stay here at the front of the motor, all right, and you look it in this direction, you will see that the motor just rotate in the clockwise direction, right? And that's the whole thing. In the simplest case of the motor, and with only a single pair of conductor. All right, here you have several pairs. Okay, but they don't use a slip link. Oh, sorry, it's not split link. Okay, they use the so-called commutator. Okay, they lay down several pairs of conductor in this part. Okay, it's just the touching area. Okay, the touching area can be either decided in terms of commutator, or the touching area can be decided as brush and split link. Okay, brush together with split link, and brushes maintain electrical power. Okay, to deliver the current or electron movement. With the rotating split link, the brushes are usually made of graphite. It is a good electrical conductor as well as a good lubricant. Okay. One thing is that you always have here the rubbing issue. All right. And for example, you have 100 watt of power. Okay, 100 watt. You know what is the unit of the power. You may not get 100 watt of rotation at the end in this kind of motor, okay, the direct current motor, because there is a friction between these one, between the split link and the brushes, and not only single touch. Okay, you have another side as the friction, so the whole motor just lose some energy or power. Okay, according to the friction here. So they use graphite, okay, so that you get less friction, and the less the friction you have, you will get better efficiency. Okay, better quality of the motor. Okay, it's not like you pay the electricity for 100 baht and you get only the torque here like 30 baht. Okay, in terms of money. It's not a good motor at all. So the good motor is that it should have a very, very small friction lost here. Okay, friction lost here. Okay, and yeah, here is the explanation to what I have shown before. And yeah, here is the front view of the motor at the beginning. Okay, you have several pairs of motor. Okay, let's start from the battery source. Okay, that's the original state. That's the origin of the whole mechanism. Here is the plus side. And what time is we have to finish at 9:50, right? 9:50. Okay. So that you have 20 minutes of break. Okay. This is the plus side, and the current just flow here, and it flow further, and it passes the brush. Okay, the left brush, and it just touch the conductor here. Okay, this is the first pair. Okay, first pair, and number one on the left. Okay, and number one prime. Okay, on the right, and both are connected together at the end. Okay, according to this figure, you can see here. This one. Okay, it will connect it to each other at the end of at the rear part of the direct current motor. Okay, this we cannot say simply. Okay, this because this one just obstruct the view of their connection. Okay, but if you look at this, okay, both wires are connected to each other at the end or the rear part of the current motor. But here is only the front view, okay, front cross-sectional view. You have the first pair, you have the second pair, you have the third pair, fourth pair, and fifth pair, okay. It's like you just divide 360 degree by 10, okay, because you have 5 pairs. So the angle between each y is, okay, the angle between this one, for example, this one is 36 degree, okay, and yeah, you count it with the 10 sector, you get 360. All right, yeah, the current will go like this, okay, and let's say this one just touch the middle of the connector, and then it's further connected to this one. I don't know, it's connected to the front, not the rear in this case, because the current just flow like this, okay, and here is the front part of the conductor vector, the current vector, right, and it's go to this one, okay, and the current flow into the, okay, here on the left side the current flows out of the plane, okay, out of this lecture note, and on the right side the current flow into the plane of this lecture note, and of course the vector B, the magnetic field vector, the blue one here, the magnetic the vector B, okay, from right to left, and you have the right hand rule, right, L to B, right, you get by using the right hand rule. L, this is vector L, which is pointing out of the plane. You rotate it to the magnetic field B, and you get the induced force on the left side, FB on the left. And this one, the vector L is pointing into the plane, right? You rotate it to the left direction, which is direction of the B. From L to B, you get the induced force upward like this. All right. And yeah, you can see that these two forces will bring you to the so-called torque. All right. And it will rotate like this. Yeah. And when this one pass the brush, okay, another type, the fifth pair of the conductor will touch the brush, okay, and this one will touch the brush, and the same process is gonna hold, okay, and the same process will happen. So you have almost continuous torque, okay, apart from every 36 degree, okay, you have the induced force, but that's enough, okay, because the rotor will have also the inertia, right? It still rotate even there is no touching point for the current movement. And that's the whole thing about the current motor. Here is the rotation, right? Rotation motion. When the brush doesn't contact any conductor, it still rotates because of the inertia, as I told you here. Inertia will keep the rotor turning. And yeah, the next one, okay, you just rotate until the 1 prime, which is actually on the right side, now move to the left side, but the same process will happen even 1 prime reaches this brush, okay, because the brush doesn't know any number of the conductor, okay, it just it's dummy, okay, its function is only to transfer the current to the conductor. It doesn't know what number you are, okay, what number the conductor is, okay, it just transfer the current. So you still have the rotation in the same process as I explained before ครับถ้ามีคำถามนะครับก็จะถามได้เลยนะเพราะว่าโอ้โหแค่ตอนเรียนห้องจริงครับปีที่แล้วอ่ะก็ยังเข้าใจยากนะครับเพราะว่ามันก็ซับซ้อนนะครับยิ่งออนไลน์อย่างนี้ผมไม่รู้จะมีโอกาสคุณจะได้ถามอย่างไรนะครับโอเคไหมครับ Alright, now let's go further to induced current and induced EMF. Okay, we don't have any example or problem regarding the direct current motor, but at least you know what happens, right? It's the extension of the idea by conductor loop and solenoid, right? Now we arrive at a good example. Before you know that direct current motor. So this is motor is the device. Okay, just transfer the electric power, right? You get the input as the electric power, and you get the mechanic. Okay, mechanical power. Okay, it's here. Oh, sorry for that. The thing that you have to pay is electricity, right? You have to insert, okay, electricity to the electric power, and what you get from the motor is that you get the torque, right? It's torque tau bien psi theta, as you have seen. All right, and that's the whole thing, okay, about motor. You pass the electric power to that, and you get the outcome or the output as the torque, okay, which is a kind of mechanical power. Okay, now let's move to the next topic. We will talk about the device that works in the opposite way to the previous device, okay, to the motor. This device is called generator, okay. It's in the same way, okay. There is input, there is also output. The input of this one is the mechanical power. Or simply speaking, you have to input, you have to deliver the TORQUE. All right, and here the output you get from this one, from the generator is the electric power. It means you get the so-called current. Okay, you get a current from the generator. Okay, you have to spend some energy to this device, and you get the output as the electricity. That's the whole story about this chapter, and let's take a look first at the simplest case of the generator. The idea before we reach the whole structure of the generator. Here you have the permanent magnet, right? And this is the south pole. This is the north pole. You know that the magnetic field line is going to start from the north pole to the south pole, right? This, right? Yeah, it will flow like this all the time, right? Yeah, everything here, everything there. All right, and this will happen. Even this, right? You can see that at this part, you have the magnetic field line pointing almost downward direction, right? This way. And if you lay your hand like this, okay, just hold it, and there is no movement, there will be no current induced. Okay, this is the ammeter. Okay, you know the word ammeter, right? Ammeter is the, anybody can tell me what is the functionality of the ammeter? Ammeter ใช้ทำอะไรครับลืมไปแล้วหรือยัง ammeter คือเครื่องมือที่ใช้วัดอะไรครับแอมแปร์ใช้วัดกระแสนะครับโอเคไหมครับ ammeter แอมแปร์หน่วยของ current นะครับโอเคไหม so if you have the ammeter here, and this is the point that is connected to the coil. Okay, the solenoid inside here. I don't know how many numbers of turns they have, but there are several turns. Okay, yeah, and one end of the solenoid is connected to the conductor, and another end of the conductor is connected to the ammeter. We want to observe, is there any current movement inside this coil, right? When you lay down your hand like this, okay, and you didn't shake, you didn't move your hand at all, the permanent magnet doesn't move at all. There is nothing happen. Okay, what you observe from the meter is that 0 ampere. Sorry, the 0 ampere is gonna happen from the monitor of this ammeter. All right, and in the same way, this is taken from another book, and here is taken from another book. Okay, the first book and the second book. And the same way, here is the multimeter, right? ผมเคยพูด multimeter ให้ 604 ดูยัง เคยโชว์รูป multimeter ให้ดูยังแล้วหรือยังครับ ถ้าเคยทำให้ดูแล้วก็จะไม่พูดมากนะโอเคไหมขึ้นกับคุณนะครับเห็นไหมถ้าบอกว่ายังครับอาจารย์ไม่เคยอธิบายเล่าเรื่อง multimeter ก็จะอธิบายให้จะหาเว็บไซต์แล้วเปิดรูป multimeter ว่ามันทำงานอย่างไรให้นะครับมีไหมเอ่ยมี response is there any response from you เคยเล่าเรื่อง multimeter ให้ฟังอย่างนี่แหละคือหน้าตาของ multimeter เลยครับมันจะมีบล็อกหนึ่งอะที่ทำหน้าที่วัดกระแสหรือแรงดันนะครับใช่ไหมคุณก็บิดลูกบิดไปโอเคyeah this is a loop of the coil, right? And it's connected to the red one, which is the plus side of the multimeter. The black one represents the negative side of the multimeter. Okay, let's say, simply speaking, we have only a single turn of the coil, the black one here. And of course, you have the permanent magnet, and the permanent magnet, we have the magnetic field lines flowing from the north side, okay, north pole, and of course, it will flow like this, right? And flow like this, and the returning magnetic field line is gonna reach the south pole here. All right. Yeah, and that's the way. If you just lay your hand like this, okay, and there's no movement, your hand just stay at the same position like this. Nothing is gonna happen. Nothing is gonna be observed on the monitor of the multimeter like this. All right, you can see 0.00 ampere happen in this scenario. Okay, that's the first state. Okay, when there is no movement, there is no induced current. Okay, and let's take a look at this case when you have magnetic field line and you start moving your hand to the left, all right, to the left like this, and of course this is the magnetic field lines, right? There are several lines, and when you move it closer to the loop, to the conductor loop, you will get the loop will feel that I get stronger magnetic field at the moment because this guy just moved the magnetic field to me, so I get stronger magnetic field line. So the first stage at the starting time, I get if I am a conductor loop, okay, I get a certain amount of magnetic field, but this guy moved his hand to me, and the magnetic field line, the north pole stay closer to me, so I get stronger magnetic field. I get more number of magnetic field line too, so I get stronger. What happened with me? If I am conductor, I try to make the magnetic field in the same level as the first stage. Okay, at the beginning, what happened? I try to produce the magnetic field line against the one here that is pointing to me. So if I am conductor, I try to produce the current in the opposite direction against the magnetic field line from this guy, okay, from his permanent magnet. And in order to produce the magnetic field against the magnetic field from this guy, the current should be induced in this direction. Okay, this one, the violet one. Okay, it's like in the first stage you have such a strong B, right? B at time time 1. All right, and you get a strong magnetic field, magnetic flux density T2 like this. Okay, because this guy moves the magnetic permanent magnet closer to me, to the conductor, if I am a conductor loop. Okay, and the vector has greater length. Okay, has more length. And what happened with me conductor? I try to produce the B. Okay, this is B. B, I would say B conductor. Okay, B induced in order to against. Okay, because before that, and the same length here. Okay, let's say this the length L, and here is also the length L. Okay, I need to create the magnetic field with with that amount. Okay, so that I get the same magnetic field as same as the beginning. Okay, okay, it's acceptable. I get the magnetic field like this. Okay, at the beginning. Okay, at the first at the starting time. But later, when this guy moved the magnetic field to me, I feel that that is magnetic field stronger to me. So I have to produce the magnetic field, magnetic flux density against the additional one here. That's the L is the additional magnetic flux. Additional flux. Okay, magnetic flux. All right, yeah, I have to produce something to be against the additional amount of magnetic flux. Okay, so that the remaining the total magnetic flux still remains the same as the first stage, and that's the behavior of the conductor นะครับนั่นคือพฤติกรรมเบื้องต้นของตาขดลวดเหนี่ยวนำโอเคไหมเขาพยายามเขาไม่ชอบอะไรมาเปลี่ยนแปลงเขาโอเคไหมคือคุณเปลี่ยนฉันได้แป๊บนึงแต่ฉันจะสร้างอะไรต่อต้านคุณทันทีนะครับในปริมาณที่เท่ากันเพราะว่าฉันยอมรับได้ฉันได้รับ10อะไร10เทสลาอย่างเงี้ย10เทสลาแต่อยู่ดีเอาเลื่อนแม่เหล็กมาใกล้ฉันได้รับ20ไม่ล่ะฉันสมมติเลื่อนแม่เหล็กมาใกล้ฉันแล้วฉันได้รับ16เทสลาอย่างเงี้ยฉันจะต้องสร้างสนามแม่เหล็กไปในทิศตรงข้ามที่มันเพิ่มมาหาฉันนะครับขนาดเท่ากับ6โอเคไหมจากเดิม10มีคนใส่เข้ามา10แล้วจากเดิมมัน10พอเลื่อนมาปุ๊บเป็น16เทสลาฉันต้องสร้างเข้าไปต่อต้านนะครับในทิศตรงข้ามเนี่ยทิศตรงข้ามเข้าไปเนี่ย6เทสลาโอเคไหมเพื่อว่าให้มันเหลือ10